Alright, so today we're looking at 5G communication matrices. So we're looking at communications and connections and how we can show those in a matrix. So social networks, communication paths and connections can be represented and analysed using matrix techniques. So for a one-step communication, these are the kind of guidelines that you have to go by. So the matrices for a one-step communication are square, okay, so that means the row and columns are the same. Binary. Binary means the only numbers that can be in there are ones and zeros. Show direct one-step communication links, okay, so that'll make more sense in the example. It will have zeros along the leading diagonal, because a person cannot communicate directly with themselves. Okay, otherwise you'd probably be a little bit crazy. And if you sum the row or the column, it'll tell you how many people a given person can communicate with. So, looking at the following example, the following network shows 4 students passing notes in class. Okay, so that's the network. That's from chapter 9. Vicky can pass notes to Stephen and Kathy, but not to Paul. So from this network, you can come up with this communication matrix. Okay, so like it said from above, Vicky can't pass notes to Vicky. You can't talk to yourself, so that's why there's 0. And that's why there's zeros all along here, because they don't pass notes to themselves. Okay, now it says that Vicky, and you can see in the network, she can only talk to Stephen and Kathy, or pass notes to them. She can't to Paul. Okay, so that would make sense that if you look at your matrix, Vicky and Paul, so it lines up here, that's a 0. Okay, and same, Paul can't send anything to Vicky, which is why that's a 0. Okay, looking at the Vicky and Paul's. Yep. And then, so that's how you fill out for the rest. So we know that Vicky and Stephen can communicate, they can pass notes. So you line up your V with your S, and there is a 1 there. And same, so you can go backwards. So Stephen can pass to Vicky. So Stephen to Vicky, that's why that's a 1. Okay, so you can fill out your communication matrix, making sure you're only using zeros and ones. This is different to an adjacency matrix that you might be used to, where we write in our matrix how many edges touch the vertice. Okay, it's not about that anymore. This is different. This is a communication matrix. And the sum, so like that last up point, the sum of a row will tell you the total number of people that that person can communicate with. So, for example, Vicky, okay, looking down the column here, there's 1, 2, so that means Vicky can talk to 2 people. So she can pass notes to 2 people, which we sort of knew. If you want to look at a row, so let's look at Stephen, his row. If you add up all those across there, so you've got 1, 2, 3, that shows that Stephen can pass notes to 3 people, which is correct, because if you look at the network, he can pass notes to all 3 of those people. So that's one-step communication. 2-step communication. It's to communicate with someone via another person. So Vicky might pass a note, so going back up here, Vicky might pass a note to Stephen, who can then pass it to Paul. Okay, so that's 2 steps, Stephen then Paul. Or Vicky might pass a note to Stephen and then he passes it to Kathy. Okay, so 2-step. So to do this, what we do is square the communication matrix. That tells us the 2-step communication links. It's worthwhile just using a CAS to calculate this, okay? Because remember, so when I say squaring, so if you have n, which is this matrix here, okay, to get n squared, hopefully you guys can remember some index laws from last year. Okay, that means you do the matrix n times n. Okay, now obviously you know from multiplying matrices that can be quite tedious, especially when you've got a 4x4 matrix, so it's just best to use your calculator. Okay, but we're multiplying our first step communication by itself. That's what this means. So two-step communication, make sure you square that original matrix. That'll tell you all the different ways they can talk to each other. So this one is n squared. It's a bit small. This is n squared. Okay, so once you square it, this can show that a note can be passed from Vicky back to Vicky in two ways. Okay, which makes sense because if Vicky starts with it, it's got to go back to Vicky. So it can either go to Stephen and then back. Okay, that's one way it could do it. Or Vicky can send a note to Kathy and then she'll send it back. So there are two ways that you can do that. So that's why there's a 2 there. That's what that 2 means. Okay, let me get rid of all this. Say, let's look at maybe this 3. Okay, so that means this 3 indicates that there are 3 ways that Kathy can send a note and it will get back to her on the second one, which makes sense because she can pass a note to 3 different people. So again, she can send a note to Vicky and she sends it back. So your first step is going to Vicky, the second step is coming back. So that's one way she can do it. She can do that with Stephen, send a note to Stephen, first communication, second step back, and same with Paul. So there are 3 ways that there's 2 steps of communication. So that's what this 3 means in the matrix. Okay, so, and then there's some more information here of what n squared can tell us, which is important. So have a read through and have a go at exercise 5G.